In today's class, we are going to solve gate questions on all logical operators. Up till now, you have studied conjunction, disjunction, NOT operator, then also the derived operators like NAND, NOR, XOR, and also the conditional and biconditional operators. So questions are based on them. First, I will give you all the questions so that you can try by yourself. Then you look at my solutions with tricks and techniques. Okay. So first question in front of a screen, pause the video, try. This is GATE 2024 question. Easy question, not that tough. Question number 2, pause the video, try, then go to the next question. Easy question if you have studied from the class. Okay. Straight away you can say the answer. Next question, again in class I have given a note straight away from the notes. Then this is a good question, and yes, let us see the solution now. Okay, I guess you have solved all the question. So the first question was, let P and Q be the following propositions. P says fail grade can be given. Q says students score more than 50% marks. Consider the statement fail grade cannot be given when students score more than 50% marks. Which one of the following is correct representation of the above statement in propositional logic? A, B, C or D? First of all, you have to see that we have to convert this English into the logical operator, right? When I see this English, it's made from two proposition, this and this, correct? But there is a relationship between them. See, P says fail grade can be given, okay? And here it is written fail grade cannot be given. So basically this line is negation of this statement. So I will say this is negation of P. Then we have a keyword when. Okay, and the next proposition is students score more than 50% marks, which is straight away this proposition, which is Q. So now we have negation P when Q. Obviously that English won't be given, you have to convert that into the operator. What's negation P when Q? Sir, this is implication, conditional operator, which says if this is the input, then this is the output, right? Negation P when Q. So negation P is the output when Q is the input. Therefore, the answer is Q is the input, which implies negation P as the output, which is present in option B. So option B is correct. Easy question, not that tough. So it was asked in set 2. Let us go to the next question. Second question in front of the screen. Let P, Q, R denote the statements it is raining, it is cold and it is pleasant respectively. Then the statement it is not raining and it is pleasant and it is not pleasant only if it is raining and it is cold. Now this seems complicated, but it is not. I told you, whenever you get these statements, break it down. Okay, go step by step. So here you have to say it is not raining is negation of this proposition. So this was P, this is Q, this is R, right? So it is not raining is negation P. And means conjunction. It is pleasant, which is the R proposition. Okay, done. Then we have and operator. Okay. It is not pleasant, which is a negation R only if. So this is a keyword. Let me highlight. This is a keyword, only if. Only if it is raining and it is cold, which is P and Q. Isn't it so? So P and Q. This is what we have right now. Let me copy this to the next slide so that you can clearly see. This is what we have right now. This is P and Q, right? Let me write it big. P and Q. How to convert this thing? Let us see. In slide, in the notes of implication, I have told you what I have told you. Whenever you have A, only if B, all the keywords I have given there, right? A only if B. What does this mean? A only is the input required if B is the output. So A implies B. It is what A only if means. A only input required if B is the output. What if I have A if B? So A is the output when B is the input. So B implication A if B means A is the output if B is the input. So you have to understand these keywords carefully, then only you will get the correct answer. So here I will say, now Answer is negation P and R, and negation R only if, so negation R is the only input required if P and Q is the output. This is our answer, which is present in which option? Option A. So option A is correct. Understood? Easy questions, right? Let us go to the next question. The binary operator not equal to is defined by the following truth table. Okay, so when inputs are 0, output is 0. When inputs are different, the output is 1. When inputs are same, the output is 0. This is what the table is saying. So which of the following is true about the binary operator? Commutative, associative, or the combinations? Commutative, not associative, not commutative, associative, neither commutative nor associative. So pause the video, try. I hope you got the answers. Or this was 2015 computer science question, and very easy question, because looking at the table we have understood the output works for the differences. When output works for the differences, which operator it is? Yes, it is XOR. So we have to say that whenever output works for differences, this resembles the operator is XOR. Therefore, in our question, this not equal to thing is basically equal to XOR. Okay, XOR. So in XOR, we know very well that both the things work. Commutative, change the position, still the output is same, or make different groups, still the output is same. So here for XOR, both the things are there. Commutative, let me write it in this way. For XOR, commutative works and associative also works. Okay, so this is our conclusion, and I hope you remember my slide. Okay, let me write that slide for you guys if you have forgotten. For all the operators, I told you about the commutative and associative, and I told you GATE examiner can ask questions from that. So the note was, therefore I always say refer my notes, that's more than enough. So commutative, associative, okay, commutative, associative, both of them, who is it? Sir, one is XOR, we know it very well now. Other is biconditional, okay, double implication. So here I have to say that XOR is commutative and associative, and by implication is also commutative and associative, which is very, very sensitive. Sir, this symbol implication is very, very sensitive. It is not commutative, not associative. There is two operator which is commutative, but in groupism it fails, in associative it fails. Sir, that is NAND and NOR. Indeed. So this is how we have remembered in our class. So straight away we can comment on the answer. What is the answer? Answer is option A. Let us go to the next question. Next question in front of the screen. Which one of the following is not equivalent to P double implication Q? Now you know in the notes I have given you and also told you how to remember the simplification of P double implication Q. One way is multiply, oops, there is rain outside, so multiply P and Q, or the negation of that, negation P and negation Q. This is one way. Then change the symbol. Okay, so and is changed to or is changed to and is changed to or, change the symbol. Again we have PQs, but now you have to give negations to one. Here P negation, so in other you can give Q negation. Okay, this is how we have remembered. And then we have one more way, which is again for and. So bracket, 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 so and, so P implies Q and Q implies P. So if you have remembered all these things, then see here, not equivalent, we have to say that negation P or Q and negation Q or P, it was present. Yes, this second thing, so it's correct. Talking about the option B, negation P or Q and Q implies P. So this is nothing but P implies Q. The simplification of P implies Q is negation of P or Q. So same thing is written here. So basically P implies Q and Q implies P, which is present here. So it's equivalent. We were in search of not equivalent. What about this thing? Negation P and Q or P and negation Q. Is it correct? Sir, one time negation here, other time negation here, makes sense, but it is incorrect. See this symbol here, and or and, that is not allowed. We had or and or. Okay, so it looks same, but it is not same. So this is incorrect. This is how you have gotten. This is incorrect. Talking about the option D. Option D, if you see carefully, negation P and negation Q or P and Q. Yes, absolutely correct. This was our first thing. So yes. Not equivalent of this was only option C. Now this is one way to solve the question where you have studied from the class and you have remembered all the notes. But what if you forgot in the exam? You may forget everything. So what to do in that case? In that case, let me copy this question and let me show you method 2. Always remember, in the chapter 1 propositional logic, the important trick is substitution. We are going to use many times this trick, substitution. So this is our method 2. What is our method 2? Let me write it here. That method 2 is substitution. Substitution will give you the answer where options will be eliminated and only one option will be remaining, right? So what we are going to substitute? P double implication Q, truth table we know, when both the inputs are same, output works. If inputs are different, output is 0. So let me take P equal Q equal 1, 1 represents true. Okay, then what would be P double implication Q? It will be 1 because inputs are same, output should be working, output should be 1. So now let us check the option. Okay, let us check the option A. If I check the option A, then 0 negation P, right? So negation 1 is 0. 0 or 1 is 1. 0 or 1 is 1, and then and with, what about this? 1 or 0. Yes, 1 or 0 is again 1, right? So 1 and 1 is 1. You can see that same result. We were in search of not equivalent. So this is same. Talking about this option. So again you have to do the same calculation. Negation P, negation 1 is 0. 0 or 1 is 1. 0 or 1 is 1. And we have this thing which is 1 implies 1. It is also 1, right? So only for TF it was 0, right? TF it is F. Otherwise for all the cases it is true, it's working. So here that 1 implies 1 is nothing but T implies T. So it is T. Okay, so 1 and 1 is also 1. We were in search of not equivalent. This is anyhow equivalent. So this is not the correct option. Talking about the option C, do the same calculation. Negation P, which is 0 and 1. It is 0 because 0 and 1 is 0. And then we have OR. Again, it would be what? 1 and 0, which is 0. So 0 or 0 is 0. So different output, not equivalent. So this is the option we were in search of. But let us investigate option D, because when you are doing substitution, check all the options. Sometimes what happen, because you have two variables, we have 4 combinations, 1 0 0 1 1 1 0 0. So sometimes it may be like for some combination 2 options are matching. So therefore you have to check whether all the 3 options eliminated and only C is left, then it is correct. Otherwise we have to do more substitutions and simplify further. Okay, so here if I see carefully, negation P, so negation P is nothing but 0. So 0 and anything, the answer is 0 only. Then here what about the thing? So here 1 I will get, because 1 and 1 is 1, right? So 0 or 1 is 1, equivalent. Therefore happily you can say odd man out was only this thing. So C is correct. Understood? Very powerful trick. Remember that a lot of questions will be solved by substitution technique. Now try this question. Question number 5, last question of the day. Which one of the following propositional logic formula is true when exactly 2 of P, Q and R are true? A, B, C or D? I know now you have learned substitution trick from me. So what you are trying to do is you are trying to do substitution. Now remember that there are two kind of people in a substitution technique. One person do substitution randomly without even analyzing the option or using some smart technique. Okay, so they are just like, I will do random substitution, and because you have 3 variables, there are 8 combinations, you choose any one and you do the substitution. The other people is a smart, okay, where they analyze the option and think, oh, what is my requirement? My requirement is my propositional logic, whichever option, should be true, provided if only 2 inputs are true out of 3, if only 2 inputs are true, which means one should be false. Okay, now if you are smart, you will think wisely and you will choose that set. Otherwise you will say randomly, oh, let me make any 2 of them true, let us say first 2, let me make it true, and this let us take as false, right? So PQ is true, R is false, and let us investigate what happens. Okay, let us investigate. So as per your first step, where you have chosen PQ as 1, R as 0, then we are getting here 1 implies 1, same input, so this is 1, so 1 and 0, 1 and 0 is 0, so 0 or what about this? 0 or, sir, this is 1, this is 1, negation of this would be 1, because R is 0, so negation of 0 is 1, so 1 and 1 and 1, it is 1, so 0 or 1 is 1. Okay, so this is true, which means this should be correct, right? They were saying that which of the following is true when 2 inputs are true out of 3. So this one makes sense. No, in substitution every option should be checked, right? So now check option B. In option B, sir, 1 double implies 1 is 1, negation of that is 0, 0 and anything would be 0 only. Talking about the next thing, this is 1 because same thing here, right? So this thing is 1, so answer is still 1. This is also correct. Here only you know that this method failed, right? Here only you know that no answer can be gotten from this substitution. You may eliminate one of the option from this technique, but you will not get the answer, right? The required answer you won't get, because you can see A and B. So here we can say that substitution failed. Okay, so this set failed to give me correct answer. That's what I was saying here, that random substitution will sometimes works, sometimes does not work, like this. So you have to be a little bit smart. So how I was smart was, I was seeing that, see, this complete thing is same to same. So what if I make it 0? Okay, I try to make it 0. So what will happen? OR means this is 0, so everything is dependent on this thing. If this is true, then the result is true. Here also, if this is true, result is true. This thing is false only, this thing is false only, so it will go. What about this thing? Again depends on this. Okay, so how to make that circled thing 0? You have to substitute this thing. Let us say P and R is 1 and make a Q 0. When Q is 0, can you see that P and 0 and anything, the answer is 0 only, because in AND, if any one of the input is 0, the output is 0. So here now everyone is becoming 0. So result is dependent on this players. Option D is 0 only, so it's false only. So A, B, C, one of them would be correct. Can you see the smart approach now? Are you getting the feeling that now I will get my answer very fast? If yes, let us investigate. So 1 double implication with 0 is what? It is 0. 0 and anything, the answer is 0 only. Then we have this thing as a 0, so the result is 0. It is not true, so option A is wrong. Option D was wrong itself, because 0, 0 and anything, the answer is 0 only, so this is wrong. What about B and C? Let us investigate B. So P double implication Q is 1, double implication 0 is 0, but negation of 0 is 1. Okay, 1, and what about r? R was also 1, so this is 1. Or anything you have, 1 or anything, the answer is 1. In or operator, if one of the input is true, result becomes true. Okay, so this makes sense. What about C? I told you, in substitution, check every option. Don't clap or don't be excited if you got one of the option correct and 2 options wrong. Okay, let us see the option C. Here we have to say what will happen. Sir, this is 0, 0 and anything, the answer is 0. Then or with this thing, this is also 0. So 0 or 0, the result is 0. So A, C, D, everyone give the result 0, which is false. We are in search of true, which is given by only one option, which is option B. Understood how smart substitution works. So this example helped you to develop concept compared to the fourth, right? So in this, any random substitution worked. So and it was easy also because 4 combination only, simple. But when there are more variables and more operators, calculation takes little bit time. So this is one of the trick which you can use in the logical operator to avoid the simplifications and arrive at the answer quickly. So I hope you enjoyed the class. Yes, that's it for today.